Welcome to our study of the fundamentals of operating systems. This series of lectures is based on the book Operating Systems Concepts, 10th edition, by Abraham Silberschatz, Greg Gagne, and Peter Galvin, and published by Wiley Publishing. I'm very grateful for the resources that the authors and publisher provided for this series. Thanks to all. So let's begin with Lesson 1, the introduction. An operating system is software that manages a computer's hardware. It's often referred to as the resource manager of the computer. In your earlier introductory courses, you should have been introduced to the concept of system software and application software. You'll recall that system software is software that controls the system, such as compilers, interpreters, utilities, and of course the operating system. Application software refers to the applications that you and I use on a regular basis. Software that serves a user's purpose, such as our word processing software and spreadsheets, management applications, and all the other apps, even games. The operating system serves as an intermediary between the application programs and the user to the computer hardware. In the earliest days of computing, before there were even programming languages, a technician would have to change switches and even move wires to perform what may have been called programming to change the function of the machine. The introduction of the earliest high-level programming languages like Fortran and COBOL improved the task immensely. But even then, the programmers still had to spend a tremendous amount of time writing instructions that had little to do with the application that they were working on. These were instructions necessary to move data around in memory, deliver the characters entered from the keyboard to the screen, spin a tape to store information, and so on. The introduction of the operating system in the early 1960s changed all of that. This very helpful software picked up that burden and allowed the programmer to devote his or her time to coding a reliable application. The operating system became the software responsible for interacting with the many components of the computer. No longer would the programmer have to write the instructions to manipulate a storage device, for example. He or she would simply have to write the operating system command to save, open, or delete. The operating system would take care of the program to actually do it. Today, operating systems may be found assisting applications in cars, appliances, smartphones, personal computers, enterprise computers, and cloud computing environments. In your introductory courses, you were introduced to the primary components of the computer, such as the CPU, memory, input-output devices, and so on. One of the fundamental responsibilities of an operating system is to allocate these resources to programs. An operating system is very complex software, and each of these services requires a great deal of time and effort to develop. Each of these services has carefully defined inputs, outputs, and functions. In this unit, we provide a general overview of the major components of a contemporary computer system, as well as the functions provided by the operating system. A computer system can be viewed as being composed of four parts: the hardware, the operating system, the application programs, and the user, as shown in this figure. While there are numerous pieces that make up the hardware of a computer, we'll limit our discussion in this series mainly to the central processing unit, the memory, input-output devices, storage, and network elements. The application programs, such as those we mentioned earlier, determine how these resources are used to solve users' problems. As you can see from the graphic, The user calls on the application software to solve those live tasks, and then the application software calls on the operating system to coordinate the services of the hardware. As in our example, the user creates the document with the word processing application, and the word processing application depends on the operating system to save to the secondary storage device or print to the document on the printer. The application software allows the user to create new product or perform some other valuable service. The operating system does not. Its function is to serve that application and user by delivering access to necessary devices and other services. It could, with a little imagination, be considered like the nurse at the operating table delivering the scalpel and other tools when needed by the surgeon. Or maybe the anesthesiologist monitoring, adjusting, and delivering anesthesia to the patient while the surgeon is performing a life-saving service. Yes, the surgeon is the one who knows how to replace that heart or create that new nose, but he or she could never do it without the efforts of those other people, and your word process document would never make it to that printer or save to that disk without the operating system. Let's talk a little about how the user views the operating system and then how the system views the operating system. The user's view of the computer varies according to type. Many of us sit at our laptop using the computer to create a new product, such as a college professor working on an online course. The monitor, CPU, memory, and possibly storage are dedicated to the user in such a case. However, the user may be using shared storage or network resources and so on. The goal of the operating system is to maximize the performance of the system, including the user's performance. In this case, the operating system is designed mostly for ease of use, with some attention paid to performance and security, and none paid to resource utilization. Resource utilization refers to how various hardware and software resources are shared. Increasingly, many users interact with mobile devices such as smartphones and tablets. In fact, these devices are the preferred computing tool for many people. They are typically connected to networks through cellular or other wireless technologies. Many mobile devices also allow users to interact through a voice recognition interface such as Apple's Siri. Interestingly, that smartphone in your bag or pocket is much more powerful than the first computer that I used years ago. Embedded computers in home devices and automobiles may have numeric keypads and may turn indicator lights on and off to show status, but they and their operating systems and applications are designed primarily to run without user intervention. They have little or no user view. From the computer's point of view, the operating system is a program most intimately involved with the hardware. In this context, we can view an operating system as a resource allocator. A computer system has many resources that may be required to solve a problem: CPU time, memory space, storage space, input-output devices, and so on, and the operating system acts like the manager of these resources. There are numerous and often conflicting requests for resources, and the operating system must decide how to allocate these resources to specific programs and users so that it can operate the computer system efficiently and effectively. Another way to view the operating system is to recognize the need to control the various input-output devices and user programs. Therefore, an operating system is a control program, which manages the execution of user programs to prevent errors and improper use of the computer. It is especially concerned with the operation and control of input-output devices. You can see that the term operating system represents a lot of roles and functions. Granted, some of that is because of the many designs and uses of the computer. Computers are found in far too many things to count, from refrigerators to spaceships. The authors suggest that an examination of the history of the computer will help explain this diversity. Frankly, if you're interested in a career in information system, you should know something about that history. It will help you understand why modern computers work the way they do. You've probably covered the history of the computer in one of your introductory courses. If not, feel free to visit my History of the Computer and Fundamentals playlist on YouTube, because we won't be covering the topic in this series. Suffice it to say that computers gained in functionality and shrank in size over the years, leading to a vast number and variety of operating systems. Well, I think that was a sufficient meet and greet lesson. Why don't we stop here, take a short break, take care of any business that you might have to deal with, any assignments that may be out there pertaining to each lesson. And when you're ready, come on back and we will begin to get into the meat of this first introductory unit.